Okay, I've noticed something today so far. I had a look at these, and if we go to spot colour, this, you see, it's almost so dark green it's almost black, and building up on the sides there. To a certain extent in there, seems to be a little bit of a difference between those two, but this one, so far, it's not building up. I've noticed on here, it's almost on the corner here, and some of it is in there underneath there, sort of thing. So very interesting. I took some pH measurements, and the difference between those two is 2 pH units. So in other words, this one here is 100 times, because it's a logarithmic scale, less acid than that. So they're more acid than that, and it's a 100-fold difference. It's a 2 pH difference between that. So I thought I'd start measuring pH, and first of all I started measuring out what looks like some sort of, I'll put it in the sun, if we can get the sun on it, or through it, through it. It was still on spot colour, but you can see that it seems to be some sort of red algae. So I took the pH, just did a simple, as you can see here, I just took a little, just a little simple pH test with this. This is only accurate for half a pH unit. It's a universal indicator. They're trying to bamboozle us with all sorts of other indicator formulations, but by doing that you're actually perverting this in a way, because this is all made up with really tough organic acids that they take sometimes days or weeks to form. You've got to use concentrated acid to form them, and sometimes catalysts as well. So they're very tough organic acids made to work in hot conditions, cold conditions, down like -40 I think it is. And it all came out from bog research. It all started, they wanted a way of measuring pHs out in the bogs in some of the Scandinavian countries, if you look it up. So, there has been some goodness coming out of research into, carnivorous plants and other associated so-called low nutrient plants. Anyway, you can see that that's basically, if you've done a lot of these things, that's neutral basically. That's around about pH 7 or neutral, which is unusual, I would have thought. But anyway, you can do this thing, wash it out, but in the real world you probably just get a brand new one if you're doing this. Now we have charcoal and polystyrene. Now polystyrene itself is neutral in pH, so we'll just I'll just put the camera down here. I know you like it that way. And whoa. So charcoal and polystyrene. Get a little. Charcoal, like paraffin candle wax, is one of the few things that actually will give us, and again it gives us like a neutral reading, which is a good indicator. Okay, so we can do that again. Wash out a container. This will stain your fingers to a certain degree. And now we try our phosphorus one, and this is slightly where it gets interesting. So we do our phosphorus one here, and we'll notice that the pH now has dropped, as you would suspect, to pH of basically about 4. When it's green it's 4, red is 1, orange is 2, yellow is 3, green is 4, and that's the way it was made to be done, you see. It was made to be done so you could be out in the middle of nowhere, under the midnight sun if necessary, and you could have an easy reference that's accurate within about half a pH unit. So when it's red, it could be 0.5 to 1.5. So that's your... Now, when we use our phosphorus with our chloride in it, or salt, we can get it, getting hard to do these things. on the edge, get it low down. But too much. Bugger. Can't put it back in the container, that would be contamination. Okay, now it's dropped by about half a pH unit, almost a full, somewhere between half. It's sort of a yellowy green, not quite yellow. So it's got dropped by half a pH unit, maybe a little bit lower than that. But as I say, it's a logarithmic scale, so you can't really sort of, by saying like say by half a pH unit, you've got to remember it's a logarithmic scale, so that is sort of a bit tongue-in-cheek in a way. But it gives you an idea that the salt has an effect on the pH. Even though sodium chloride is supposed to be a neutral salt, when you make it up in batches in large quantity, it will actually give you a pH of around about 8. So it's 1 or 10 times more alkaline than it should be. So do you make the assumption that the salt you have in it is not pure? But I've even experimented with so-called, analytical sodium chloride, and even that's not neutral. So why they call it a neutral salt? Whether it's just something left over from the old times, I don't know. Back in the old day, for some reason, it was neutral. I don't think it's going to be a temperature change that much. Most things are supposed to be done at 25 degrees, and if they're not, you're supposed to specify that they're them, but you never know. It could be one of these things that just lingers on. Everyone calls it a neutral salt, and no one's bothered to check sort of thing. But if you check your salt, and various degrees of salt, they could be slightly contaminated with something. I mean, what if you contaminate something with a little bit of sodium hydroxide in there for some reason, or it's somehow forming a little bit of sodium hydroxide in there? Well, that could explain the 1 pH difference usually that you find with so-called neutral salt in quotes. Anyway, I just thought I'd do that for you. As I said, this was just done with popcorn and charcoal. That's all that was done. It's water, popcorn and charcoal. It took a while to get going. At first it went green, and then it went red. So this is, as I said, seems to be something strange about sphagnum moss. The greenness seems to be almost identical, the same greenness as the green of sphagnum moss, and this redness is almost identical in colour to the colour of the mosses go when they go red. So I'm thinking, do we have some sort of thing like a coral, a symbiotic relationship? Sorry, did I pull that out of me talking over a blurred thing for? So so this so we got something like a bit like a coral. We have a symbiont that can actually change colour, or does it change colour because there's more than one symbiont and one symbiont is ejected or something? So it's green while you got everything's hunky-dory, but when something goes wrong, the pH goes up to neutral, something gets jettisoned, and you see the underlying organism. One organism dies out, and then you're left with the red organism. And I've also noticed on hot days and cold days, it moves. So it is a lot of, I don't know if it's actually alive, but it seems to be maintaining itself. So it's not dying out sort of thing. It's not all dying and sinking to the bottom. And on hot days it changes, and on cold days it gets a slightly darker, very slightly. You can see it seems to get more intense in the colour on cold days. And I've been watching stuff online. They're talking about things with biofilms and things like that actually absorb radiation from the environment in the, I think it's like 270 nanometer range, and you can actually get energy generated in these biofilm layers in the corners and on the side sort of thing. And they're suggesting they can actually make in quotes a heat battery. So you might want to look that up on it. I think it's to do with structured water. It came out of structured water sort of thing. So that's different to the other type of water, and it's also different to grander water as well and things like that. So there's 3 different avenues of water at the moment that I've come across online. One is to do with biofilms, one to do with lasers, another one to do with galvanic magnetizing of the water as it goes through sort of thing. So anyway, which came out of a copper mine, which is strange because you think copper is, you're researching the copper mine sort of thing. So, which continent on the world that has the most, has ever had the biggest copper mine that's ever existed? It's Australia, the most saltiest bushfire-prone continent on the planet with the most CPs, the most diverse range of CPs. Peat, what's the most abundant micronutrient mineral in peat and related things like that? It's copper, and yet CPs and other related plants aren't supposed to like copper. So there's something oh, okay.